is about 3.6 times 10 to the 6 minus 6 newtons. So if you demonstrate the weight of this object acts downwards, the force is attractive towards this plate, what we can then do is calculate the size of that force, because we know the weight is acting downwards. We know what the angle is that's just here. So we can calculate using a simple triangle. If we know the magnitude of this force, we can calculate the magnitude of this force. So taking similar triangles, 1 times 10 to the minus 5 newtons downwards, tan of 20 degrees gives you the opposite side over here. So you've got 1, 2, 3 triangle. That's the force that you're given. That's the force that you need. So you know that size, tan of that angle gives you then this value. Yep. They would be then looking at, mostly it's the application of the formulae. And the most difficult thing, to be honest with you, Charlie, is identifying which formula you should be using in the first place. Marking in lines, that's fairly straightforward. Potentials and so on. I'm just, let's have a look. What was that? Yeah, I'm just having, let's, projectile comparisons. Okay, all this is doing is trying to give you the equivalent to what we would have found in mechanics. So if we fired an electron beam through here, the interaction of that beam would allow us to equate that to the action of a projectile inside a gravitational field. So what you've got now is you've got a potential between these two, and you've got an electron. So you've got an electron with a negative charge inside a positively charged field. And all it's trying to do is to get you to interpret those. The kinetic energy here, for example, force times distance. Yeah. I'm just trying to think if there's anything else. Yeah, yeah. No, this is a specific case, Charlie. This is more, I would have said, extension work. So this would have been for those moving on that got through the questions very quickly, wanted something a little more challenging. And as you can see down here, you are using the full formulae. So you're using the charge formula, force mass times big mass divided by r squared. It's not difficult, provided you calculate that's gravitational, this is electrical. Easy, yeah. Earlier parts, yeah. Um, and I probably agree with you. I don't think we would have done that as a specific lesson to cover that type of material. Yeah, Yes. Yeah, the turning effect here. We did mention Fleming's left-hand rule. Force is magnetic field times current times the length of the piece of wire. So we have covered it. Um, so again, this is force equals BIL. So it's just rearranging the formula. Field. That's a tough question, this one. So um, don't get yourself in a state about this. This is a tough question. Oh, definitely. Yeah. This is an old exam question, and it does require. No, was it question 3? It's this one here. It's question 2. It's question 2. Yeah, that is very tough. I think. What questions? I have lesson 9 here. Lesson. No, no. Not with this section here. I purposely left that one out and didn't include this. Yeah, I mean, you've got answers in here which give you the correct solutions, but I don't think, again, these were exam questions. Transformers, definitely, we did cover that. Yeah, that's where it did come from. That's why I've not looked at that at all, Charlie. Oh, Faraday and Lenz. Yes. Just one moment. Let me just put it to this one. Okay. 240 physics. Faraday. Let me just do a search and see if I can find Faraday. Well, it's referring me back to what I've already given to you. I wonder if there's. Yeah, I think that with screenshots, no physics apparatus. Which ones are these?
In this video,
Electric
we're going to
fields. Let me try another search.
changes or if the area.
I know which books I have in the office. that would allow me to. Oh, how do I see this? Let me change this to list. Electromagnetic waves, wave particle duality, electric fields. No, that's the same stuff. It's electric fields, PowerPoint. Nope. I think, let me just have a look at that. No, that they all seem to be based around what I've already given to you. So I can't. Yeah, if we look at the end, I can do that. Let me just open this presentation. How do I do that? There. You might find there are some references at the end part in the additional section. Uh, Point charges, Coulomb's law. No, the questions came from the textbook I used for this course. Internet links. No, they don't work either. No, you see, the extension questions I put in there would be on the assumption you have the textbook that I use to produce the presentations. I'm just trying to think if I've got a copy of that book in school. Are you in school at all? 12. I've got a spare copy of the book that I used. That I can bring for you, Charlie, and there's plenty of questions in there. Some of them, one of them I know, I've worked all the solutions. So I've got one copy of the book, and I have a feeling it's in my box of packed things I did when I retired. So I'll have to dig that out, and that'll take me a week to get them. So, but I've got another textbook in school. I know that's on my shelf. So you can have that to have a look through. And that will give you all levels of questions from, end of section questions to topical questions that came from exams. Oh no, it's the textbook. It's the textbook that goes with it. And these come at the end of each chapter. Um, Now, I have, and according to Miss Raja, I should not be saying this to students, I have electronic copies of virtually every textbook I've ever used. So Walker, which is the one we used years ago. Mhm. Oh yeah, that will cover it. There'll definitely be questions in there. So you could look at the end part of the chapters. So yes, then there would be questions on flux, on energy, on Lenz's law, on the induction. Yes, that will all be in there. Yeah, I understand. Have a look in there, Charlie, and then if I'm in next Thursday, if you want, I mean, if are you near to school or? Oh no, 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 no. Then that's not what we want. Um, I can give you the week following one of the textbooks, and you might find that of interest anyway, just to have a look through it. But if you do find yourself going into school, let me know, and I can ask somebody to get the book for you before next or 2 weeks' time. Okay? No problem, Charlie. Thank you for calling and thanks for your understanding. Anything else I can do for you, just let me know. All right. Thanks a lot. Have a good weekend.